Hello viewers, welcome to After Hack video series. In the previous video, we have presented using the Metasploit Framework on Windows operating system. In response, we have received a lot of queries on what the NetApi vulnerability actually is. To reveal, we have decided to present what goes on the backend in NetApi vulnerability. What I'm going to show is I'll demonstrate the attack very lightly and then I'll explain what goes on at the backend. So let's start. This is the Metasploit Framework. I'm using NetApi Vulnerability. You can broaden your search and use the exploit according to you guys, but since we are concentrating on Metasploit Framework using the Metasploit session, hence I am using NetApi Vulnerability and the payload as Metasploit again and again. I'll use the exploit. Used it. I need to set the options, and it is my victim machine's IP or 204.133. It is set. I'll set a payload which is Windows /Metasploit /reverse TCP. It is set. Now I'll see what options I can use. I will set lhost 140. This is my machine's IP, and I'll do exploit. And you can see that I have received the Metasploit session, and now I can execute whatever commands I want. For example, I'll use a shell command. Now I'm into the command prompt of victim machine. What goes at the backend is an issue. So I'll show a small presentation regarding the NetApi vulnerability. So here's a discussion on MS-08-067 NetApi vulnerability. This presentation has 3 modules. In the first module, we'll deal with the scenario of the attack on server service vulnerability. In the second module, analysis of the attack and exploitation is discussed. In the module 3, security measures implementation will be provided. So carry on to our discussion. When this vulnerability was launched in 2008 by Microsoft, a Trojan was released. What the actual role of the Trojan is, it prepared a file nx.exe where this x denotes an integer. The size of the Trojan is 388 KB. That is a very small size, and you can use any physical hard drive or pen drive to give the Trojan to your remote victim. Next, what nx.exe does is it pings to a IP 202.108.22.44, and operating the whois query on this IP, we have received that this IP belongs to China. Next, the nx.exe drops a sysmgr.dll file in the system32 WBEM folder and registers a service, maintaining service. What this maintaining service does is it created 2 registry keys. One is this service DLL registry key, which is in the system root WBEM sysmanager.dll, and a service main key, which is equal to service main function. What the role of these keys is, they created a ping command to Google in order to check the connectivity to the internet, and then they check the registry for presence of some security softwares like Kaspersky, Trend Micro, OneCare Protection and Kingsoft. Various other softwares were searched, but in order to optimize our presentation, I have displayed these 4 software distributions which were checked by the remote Trojan. Next, what is the actual role of this Trojan is to download additional malware from some remote end, from some remote server. The remote server IP is 59.106.145.58, and on performing the whois query, it was received that server was situated in Japan. That is, the Trojan, after being installed to the remote victim, will connect to the internet and then ask for a remote server to download additional malware. In addition, he supplied a GET request. The GET request format is like this: test2.php, where variables are ABC and values are value 1 and value 2. There are two variables, ABC and DEF. What ABC is? ABC is the antivirus version used by the victim operating system, and DEF is the operating system which is used by the victim. In addition, the Trojan sends a cookie to the remote server. The content of the cookie is AES encrypted, and they send Outlook Express credentials, protected storage credentials, and MSN support.NET credentials to the remote server in order to explore how the victim computer can be exploited easily and effectively. In the next part, the GET request in response will send a cab file. What this cab file will do is, it installs winbase.dll and install.bat on the victim computer and register a service with a UUID. What a UUID is? Universal Unique Identifier. This universal unique identifier related with the service sends malformed DCE RPC requests to the victim and exploit the system. In the Metasploit framework, we are doing all the same, but we are using the NetApi vulnerability. What we are exploiting is, we are exploiting the parsing flaw in the path canonicalization code of the NetApi 32.dll file. As a result of the exploitation, we are bypassing the DEP. Now you all may be wondering what a DEP is. DEP is data execution prevention. Now what execution prevention actually is? It is a mechanism or a combination of software and hardware which restricts a particular program to write some code on the memory block or on a memory page in order to secure the system, and it uses the functionality of ASLR, which is address space layout randomization, so that the locations of DLL and the loading of DLL can be randomized, and data execution prevention works accordingly. Surprise, surprise, DEP without ASLR is bypassable, and in the operating systems up to Windows Vista, DEP lacks the combination of ASLR, hence we can exploit these operating systems very easily. Windows 7 is very secured because it uses a better combination of DEP, data execution prevention, and ASLR, address space layout randomization, plus they have an additional feature of password protection on the particular ports which are appreciated for attacking. To bypass this password protection, one needs to be authenticated to that particular port. Now we will discuss a simple attack scenario of the NetApi vulnerability. When we click exploit, what happens is, it creates a TCP connection using the connect function, and in the next part it creates a transport layer connection using this SMB login function and attacks the return to library attacks and exploit the system. If DEP and ASLR both are present, then this return to library attacks cannot work properly, and then we will do a bit of assembly stuff. Right now you all may not get what actually the assembly stuff we will be doing, hence I will make a different presentation for the assembly basics, and then I will show you what assembly stuff we can do to exploit a particular system, and hence the hack is complete and we have received a meterpreter session. You all may be wondering that why, when you all install firewalls, antiviruses, and still that meterpreter session cannot be detected by firewalls is, the reason is because attackers normally use randomization of non-static attack portions, and what these firewalls and antiviruses are capable of, they can detect only static portion of attacks and signatures. Hence the systems are exploited very easily. You all can broaden your search and can exploit Windows 7 operating systems and more other operating systems which are released regularly. So kindly go through this presentation again, kindly follow the page, and in the next presentation we will show a lot of good more hacks. Kindly send your feedbacks, because I am very interested for your feedbacks and they will make me make better videos. Thank you for this session. Have a good day.